Good afternoon, good evening, everyone. Welcome to my session. My name is Anil Inamdar. I'm the head of data services for NetApp Instaclustr. And today I'm going to talk about how to harness OpenSearch as a vector search database to optimize GenAI accuracy. So here's a quick agenda. We'll start with a short quiz, and then we'll talk about the goals and objectives of this session. We'll talk a little bit about vector search, OpenSearch fundamentals, and how to use OpenSearch in RAG. And we'll talk about what RAG is. And obviously, I will spend some time on optimizing OpenSearch for vector data loads. In the end, I will also talk briefly about NetApp Instaclustr. I think everyone probably has heard about NetApp, and you might be wondering what NetApp Instaclustr is. I'll talk about that, and we'll talk about next steps. All right, so a short quiz. It's just for fun, just to set the context and lighten up the mood. So open source search and analytics engine that serves as a vector database. OpenSearch. Yeah. Good guess. Okay. What type of database stores embeddings for similarity search or semantic search? Vector database. All right. What is the term for AI generating confident but incorrect responses? Okay, hallucinations. We all know that. We all have experienced that probably. What technique combines retrieval from external data along with an LLM? RAG. Okay. And does anybody know what RAG stands for? Retrieval augmented generation. All right. Excellent. So in GenAI, what's the opposite of hallucination? Grounding. Okay. So we want to reduce hallucination. We provide them some external data and factual data to ground it, to ground the responses. All right. So some of the goals for this session are obviously enhance GenAI accuracy, reduce hallucinations, improve contextual relevance. And you are in an OpenSearch conference. So most of you are already using OpenSearch. So how to leverage the existing OpenSearch investment? So we'll talk about that. And how to implement a scalable RAG architecture. We'll talk about RAG a little bit later in the slides. Optimize performance for AI workloads. And enable flexible open source innovation. Obviously, we are using OpenSearch, which is an open source solution. So there's no vendor lock, there's no technology lock. Okay, let's talk about vector search and OpenSearch. So these are some of the examples I gathered, which are real life examples where I think in 2023, Mata versus Avianca, the judge sanctioned one of the attorneys for citing non-existing legal case. Then in Melbourne, Australia in 2024, a lawyer submitted AI-generated reference for a marital court proceedings. Again, he was also cited. There were fake software that LLMs have recommended. Huggingface.cli was downloaded like 30,000 times. There was a ChatGPT that falsely accused UCLA law professor for sexual harassment. So what is happening here? There are many other use cases. So what is happening here? So the LLMs or the ChatGPTs or Gemini or whatever ChatGPT, whatever LLMs you're using, they're hallucinating. And there is a reason for that hallucination. And we want to reduce those hallucinations. And one of the biggest reasons for hallucination is that for every LLMs, they're trained on a particular set of data. And that data has a cutoff date. And if the data is beyond that, maybe the LLM doesn't know about it. Maybe you're working for a particular industry where the data is fairly proprietary, it's not open to everyone, and LLM do not have access to that. So if you don't have access to the relevant data, it can hallucinate. And to reduce hallucination, if you provide that data externally, and we'll see how we can do that, you can reduce hallucination. So that is what we'll talk about in this session. So everybody has heard about like keyword search, okay? When we search in Word document or a Google, or we provide a keyword and it goes and finds everything related to that keyword. We are introducing something new, which is the vector or semantic search. So I just wanted to quickly compare those two. So keyword search, they match exact words. Like if you are searching for a car, a Toyota, it'll go and look for Toyota, the word Toyota. Vector search or semantic search will go beyond that. So if you're searching for dog, it can also retrieve responsives that are puppy or man's best friend, things like that. Underlying technology for keyword search, it is usually inverted index. And for vector search, it is vector embeddings. And we'll talk about vector embeddings and what those are. Query understanding, for keyword search, is literal. You give the words, and it'll look for those queries, look for those words. With semantic search, it's contextual. It'll find the context. So the keyword search is best for precise queries. If you're searching for a code, known item, vector search is best for complex queries where you're looking for some intent, similarity, recommendations, things like that. And there's an example I'm giving there. Like if you search car safety, semantic search will look for car and safety or a few other combinations, but will not go beyond that. Semantic search, on the other hand, may come up with documents or results like vehicle crash tests or automobile airbags and things like that. So the keyword search, the pros are it's fairly fast, it's efficient, and the computational costs are low. But the cons are if there's synonyms or typos, or it doesn't go beyond the actual literal search. It doesn't go beyond. So for vector search, on the other hand, can understand nuances, synonyms, things like that, but it is costly. So those are kind of those are the two things that we have to compare. I talked about vector embeddings. Okay, I think many of you might know what vector embeddings are, but I have a question for you. Have you heard about this equation? King minus man plus woman equals what? Queen. So how did we get that answer? How did we do? So basically, here we are doing arithmetic, okay, using text. Okay, how do you teach that to a computer? How do you teach that to an AI model? Okay, and that is where the embeddings come in. So what happens is whether it's text or audio or video, these models convert those into something called as embeddings. Embeddings are nothing but a set of numbers or array of numbers, and these array of numbers help you compute. So here, in this examples, we have come up with a number for king. We have come up with a number for man. We have come up with a number for women, things like that. And king, the numbers, numbers form between royalty and say male. And if you remove male, only royalty is remaining. And if you add women, now it becomes royalty plus women. And in that array, you can search and see that, hey, the nearest number for that is queen. So that is basically you're teaching the computer how to do arithmetic using text or audio or video or anything else. I think so. That is what embeddings are. So why vector search matters for AI? So number one, vector search enables semantic search beyond keyword search. Okay, that's one big thing. It improves retrieval relevance accuracy. Basically, hallucination is not the only issue that LLMs have. Sometimes the data is incorrect or data is incomplete, okay? And that can be resolved by providing relevant information to the LLM models. Then again, they hallucinate, okay? So key to reducing hallucination is also vector search. Vector search is also a foundation for the RAG, which we talked about, retrieval augmented generation, and we will go a little bit briefly what that is and how we can use OpenSearch to reduce hallucinations. And one big thing about OpenSearch is that we can enable both hybrid semantic search, keyword search, as well as multimodal search. Now, case for OpenSearch. Now, OpenSearch is already an enterprise-ready and proven software. It is adopted across industries for large-scale search and analytics. It handles production workloads. It is open source, and it is extensible. So basically, there is no vendor lock, there is no technology lock, and lots of new extensions are coming up. So you can start using it right away. Also, one differentiation that OpenSearch has with other technologies is that the vector search is native. So we can do native vector search, and it already has the keyword search, so you can do hybrid search as well. Cost effective. So I talked about cost effective already, and there are two factors there. Number one, OpenSearch itself is open source, so there's no licensing fees. Plus, you don't have to use an external vector database. Okay, so that's another thing that is saving you cost. And again, you have a unified search platform. So with OpenSearch, you can do keyword search, you can do semantic search, and you can also do analytics. So some of the vector search fundamentals in OpenSearch. So the KNN plugin is already built in. Okay, and it enables fast, scalable, approximate nearest neighbor, ANN search as well. And it supports dense vector field, sparse vector fields. Okay, I think I'll go a little bit deeper into that. We talked about embeddings. Embeddings are nothing but these numbers or array of numbers. With dense vector, every element in the dense vector is populated with a non-zero number. In sparse, not every element in the array is populated with a non-zero number. An example is that for dense vectors, we can populate everything semantics or contextual for a particular, like for example, the example I gave of dog. With dog, you can have whatever, puppy or man's best friend or canine or whatever. Okay, you can add several contexts and for dense vector. Sparse vector, you don't have to populate every vector, every element in the vector. And so those are two different types. And again, depending on your use case, you can enable those. And again, you can use hybrid search, both semantic as well as a keyword search and metadata filtering. So based on this, you can come up with your search strategies. You can have a lexical search or the keyword search strategies. You can have semantic search strategies. And obviously, you can combine those two in hybrid search strategies. So RAG and OpenSearch. So we talked about RAG a little bit. So what is RAG? So RAG is nothing but it combines a large language model, the chat GPTs, with external data. Okay, and we talked about it, why we did it. So why it matters. So LLMs are really powerful. Everyone has used it. It has saved me a lot of time. I'm sure it has saved a lot of you a lot of time as well. It can create documents. It can edit documents. It can provide suggestions. It can do queries. It's kind of changing the world. However, there is a challenge with some of the LLMs, and that is that there is a training data. For training data, there is a cutoff, and there is a missing domain knowledge. How do you overcome that? So without providing this external source for that domain-specific data or the data that was created after the cutoff date, you need to. So basically, you need to provide this additional context for the LLMs to reduce this hallucination. So how does RAG work? So when you do the query at the query time, you take the query and don't give the query directly to the LLM, but you do a search in the embeddings that you have already created for the external source or your domain knowledge. Based on that, you change the prompt. Okay. Now LLM has the new knowledge as well as the existing LLM knowledge, and based on that, it will create it'll create a response that is more grounded, and it will reduce hallucination. So those are some of the benefits that we have with RAG. And I will take a quick example of how to use OpenSearch in RAG. So here, the first step is to ingest all the data that is, provide more context. So basically, ingest all the data that is domain-specific, your industry-specific, data that is created, that was created after the cutoff date of the LLM. And in this case, I'm taking an example of a document. With this document, you divide those into like text analysis and create embeddings. With once you do text analysis, you can store that in inverted index, and everybody who's using OpenSearch probably knows that. The second is create embeddings and store that in a vector database. Now, to create these embeddings, you will need some embedding model like Hugging Face or OpenAI. And Hugging Face or OpenAI, they have some restrictions, parameter restrictions, or token restrictions. And for that, you may not be able to convert the entire document, and you may have to chunk it up in small pieces. So that is what the chunking means there. So now, in this here, we have created this new data source. We have created inverted index. We have created the vector embeddings. And now, when somebody new person queries, we do the same thing. We divide that into text analysis and embeddings. And with the text analysis, we take that text and do a search in inverted index. And with embeddings, we do a search in the vector database and create result. And that result is used to provide that to LLM. So with that result, we build the context. And what is the context? Context is the most relevant combined results of both inverted index and vector embeddings, and the previous conversation. Okay. Based on that, you create a new prompt for your LLM, and then give that prompt to the LLM, and then get the relevant response, which is grounded, okay, and based on the actual data. And then you provide that response to your user, as well as save that response for the context for the next query. So that's kind of the flow. So optimizing OpenSearch for vector workloads. So there are several items I have listed here, and I was talking to my OpenSearch experts on my team, and they came up with like maybe around 10, 12 slides for each of these. Not each of these, all of these. It will be beyond the scope of this meeting to go over that, but I have included those as part of the appendix, and those are available to you, as well as you can contact us anytime to go over this. So I will go briefly about I will discuss some of them, like select optimal hardware for vector workloads. It's kind of a no-brainer, but there are certain GPUs and CPUs you can use, so you can use that. Enable KNN plugin and define appropriate vector field types. Design efficient indexing strategies. You select suitable embedding models, and there are hundreds of there available. We have some recommendations. Choose appropriate vector search algorithms and libraries. Define chunking strategies. We talked about chunking, and again, there are some strategies that we have recommended. Enrich documents with metadata filtering and contextual relevance. Leverage bulk indexing. Build hybrid retrieval queries combining keywords, vectors, and metadata. So I think for each of these, there are additional details I have in the appendix, and you will have a copy of that. But if you have any other questions, you can contact us, and we can provide you those. So we talked about vector search, we talked about RAG, we talked about how we can combine vector search with the prompt and reduce hallucination. So here's a real life use case. There was a financial firm, and they created a GenAI chatbot. And the goal of the GenAI chatbot was to answer compliance related questions quickly. For example, like what are the new SEC disclosure rules for Q2 filings? As soon as it was released, they realized that it is hallucinating because it was standalone. There was no RAG there. And it cited regulation clauses that were revised later on. And again, it did not know about that. So it risked compliance. So the company took a decision to kind of fix that, and they implemented RAG using OpenSearch. And once they did that, so the way they did that was they took all the PDFs, all the regulatory PDFs, all the filings, and they created embeddings for those. So that was the external source, and they provided that to the LLM model. And once that happens, the hallucination dropped significantly, and the chatbot started making citations and giving a reference from the data that we already provided to it. So this is a real-life example where hallucinations were reduced significantly because we provided the relevant information to the chatbot. All right, so I think I want to talk briefly about what is NetApp Instaclustr. I think everybody probably knows what NetApp is. We are the probably world's #1 storage provider: file storage, block storage, flash storage, cloud storage. I think Jensen Huang, who's the CEO of NVIDIA, he had a keynote, I think last year, where he had mentioned that 50% of the data in the world is stored somewhere on NetApp storage. So we are the #1 in storage. However, you may not know what Instaclustr is. So Instaclustr was a 10-year-old startup that NetApp acquired. And what Instaclustr did was, we are open source data technology experts. We provide all the technology that I mentioned here along with OpenSearch. So we help you with storage technologies like Postgres and Cassandra, SQL and NoSQL, Kafka for streaming, ClickHouse for analyzing, OpenSearch for searching, and obviously for Cadence for orchestration. And we can help you with all this technology on any of the clouds of your choice: AWS, Azure, Google Cloud, or on-prem. And so these are the services that we provide. So our flagship service is our managed platform, which is so with managed platform, you can deploy any of these technologies in like 5 minutes. Okay, you can deploy OpenSearchClustr in 5 minutes on AWS or on GCP or on Azure or on-prem. You can deploy Postgres, you can deploy Cassandra cluster in any of the cloud of your choice. So that's our flagship product. The second thing is support. Because these are open source technologies, there is no phone number to call. So if there's a Microsoft or Oracle issue, there's a phone number. But for open source, there's no phone number. So who do you call? So you can call us, and we'll provide you 24/7 world-class support. So that's one. And consulting, which I lead. With consulting, we provide end-to-end solution, all the way from an idea to strategy to architecture to development, deployment, training, followed by support and managed platform. So we cover the whole gamut of development. So that's what Instaclustr does. And some of the things that differentiate us from others one is multi-cloud and multi-technology, meaning there are many companies that focus on one cloud, that focus on one technology, and I call them one-trick pony. But we provide help with all the major clouds, as well as multiple technologies that you need. We are 100% open source, so we haven't forked anything. We haven't forked anything, created a new product, and started making money on licensing. We don't do that. We contribute back to the project, and we help you with the entire end-to-end journey that I talked about. So one partner for end-to-end journey. So those are some of the differentiating factors. So the next steps. So I think the key the key takeaways for this session are, you are in an OpenSearch conference. So you already are using OpenSearch. Okay, so you have already invested in OpenSearch. You can leverage that. Okay, if you want to reduce hallucinations or use RAG, you can always exploit the existing investment. Second, there is no need for investing additional money in a vector database because vector search is native to OpenSearch. Once that happens, so you have a keyword search and you have a semantic search, so you have hybrid search, which delivers superior RAG performance. And with proper configuration and tuning, you can reduce hallucination by 40%. Obviously, that number varies depending on your use case. So what are some of the next steps? So you can assess your current OpenSearch deployment for vector readiness. And we can help you with that. Start with a proof concept using a subset. Again, we can help you with that. Benchmark against a proprietary solution, maybe a proprietary vector database, and see how different it is or how similar it is. You can implement monitoring for vector search. You can join the OpenSearch community. And as I said, we can help you with any of those items. I think that was my presentation, and as I mentioned you, there is in appendix, I have included all those recommendations for performance. But I will stop and see if you have any questions. Yes, sorry.
So how is your service different from the AWS?
I'm sorry?
How is your service different from AWS? I think they also offer an OpenSearch service, right?
Yes. So again, it's not different, but we support 100% open source OpenSearch, and you can deploy that on AWS as well as Google and Azure and on-prem. So that's one big difference there. Yeah. Any other questions?
I have one.
Sure.
So can we deploy across multiple clouds, like for redundancy with OpenSearch? Will you synchronize nodes across the multiple clouds?
So not with OpenSearch, okay, but with Cassandra we can. Okay, so we will move there at some point. With Cassandra, we can deploy one data center in Azure and one data center in AWS. But for OpenSearch, at this time, we are not doing it. Anybody knows the answer if you're doing that, or?
Yeah, we actually are doing using.
Oh, sorry, you're doing it. Okay.
Yeah, using cross-cluster replication, we can do that actually. So yeah.
Okay. So. All right, so I think, so these are closer to the product team. So I'm from the consulting team. So yes, they are already doing that, yes. Any other questions? If not, thank you very much, and enjoy the conference.